All right, let's look at your inclined plane questions from homework last night. Page 191, number 24, says a 1975 kilogram car, so we could put that in here, is parked at the top of a steep 42-meter long hill. Now, whenever they tell you the length of the hill, it's the length of the hill. It's this distance, okay? It's not the distance tunneled into the ground. No one's tunneling in here and finding the length. The length of the hill is how far along the hill are you going, okay? So this is 42 meters. It says if the car starts to roll down the hill, so it's telling us the VI is 0. It's telling us the delta D is 42 meters, and it wants to know how fast will it be going when it gets to the bottom. What's the VF? And it says neglect friction, so there's no friction acting on this car. Okay, it's just sliding down the hill without friction. So we're going to do the sum of the forces. I've already drawn in my Fn and my Fg. It's parked and then it begins to roll. There's no downward force. So the only, like, you're not stepping on the gas. So the only force acting in the x direction without friction is Fgx. So we want to find our A. So in the first part, we do some of the forces in the y direction like we always do. It's not moving in the y, because remember we've tilted our axis and the y is now this way. So that'll give us Fn minus Fgy equals 0. So Fn will equal Fgy. And if we take a look at our triangle, Fgy is the adjacent side, so it should be cos theta is equal to Fgy over Fg. So that means Fgy is equal to Fg cos theta. Okay, so Fgy is really then Fg cos theta, which is really mg cos theta. So Fn is equal to mg cos theta. Now you could fill the numbers in here if you want, but they're not going to be pretty because it's a 1975 kilogram car, 15 degrees. No way, I'm not filling my numbers in. I'm going to leave it like this until I absolutely need to fill my numbers in. And now I'm going to go to the x direction. Sum of the forces in the x direction is equal to max. And in the x direction, the only force I have is Fgx. And that's equal to max. And you know what? I just did the forces in the y and I didn't need to because there was no friction. In the x direction, if y was cos, then x should be sine. So it should be Fgx over Fg. So Fgx should equal Fg sine theta, which of course will be mg sine theta. So this is Fg sine theta is equal to max, and so mg sine theta equals max. And look how kind the textbook was and didn't need to be. You want to solve for a, so divide both sides by m, and they just cancel out. So you don't need to do that yucky math with the 1975. It's just going to be 9.81 meters per second squared times the sine of 15, which you can do. Well, I can't do it in my head because I don't know what the sine of 15, unfortunately, in my head is. But my trusty calculator can do it. And we get, I think, even though my calculator was moving around, I believe we get AX is equal to 2.539 meters per second squared. Okay? So that is the first one, number 24. Number 25. Number 25 says starting from rest. So again, VI is 0. Starting from rest, a cyclist goes down a ramp at a professional biking track. The ramp has minimum legal dimensions, 1.5 meters high and 12 meters long. Again, length of the ramp is this way. This is 12 meters. From that, we can get our theta, because sine theta is equal to opposite 1.5 meters over hypotenuse 12 meters. So you can get your theta. 1.5 divided by 12 inverse sine. It's 7.18. 7.181, I might keep an extra digit there. I'll try to keep it all in my calculator, is our angle. So find the acceleration of the cyclist ignoring friction. So ignoring friction, then there are no forces. Whoops, these two lines look an awful lot like forces. Sorry about that. They're really just to show you the length. So we can, for the A part, we don't have to do the y direction. Just sum of the forces in the x direction equals max. And so that's going to be fgx is equal to max. From up here, fgx should just be fg sine theta is equal to max, which means mg sine theta equals max. Solving for a, so the m's will cancel. So ax is just going to equal 9.81 meters per second squared times the sine of that 7.181, etc. So multiply that by 9.81 and you should get 1.22625. 1.22625 meters per second squared. That's part A. Part B says, find the acceleration of the cyclist if all the sources of friction yield an effective coefficient of 0.11. Okay, so now there is friction, and of course friction will be going this way. So now we do have to do sum of the forces in the y equals may. It's not moving in the y. It's going to be fn minus fgy equals 0. So it's going to be fn equals fgy. And just like up here when we did it, when we didn't need to, so I'm going to cheat and save time, we will find that fgy, which is somewhere over here, is fg cos theta. So this then is fg cos theta, or in other words, mg cos theta. And even if you wanted to, I don't think you can fill in your numbers because you don't have an m. So sum of the forces in the x direction equals max, and this time in the x direction there's fgx minus friction is equal to max. Still solving for a, so it'll be mg sine theta minus mu fn over m. But fn is mg cos theta. So it'll be mg sine theta minus mu mg cos theta over m. The m's are all going to cancel. And so we're going to be left with ax equals g sine theta minus mu g cos theta. And now fill in your values. So 9.81 meters per second squared, sine of, what was it, 7.181 minus 0.11 times 9.81 meters per second squared, cos of 7.181. And when you do all that, you should get, so minus brackets, 0.11 times 9.81 times 7.181. So my angle's a little bit rounded this time. I think, oops, I might have screwed up, but I think you get 0.15561 meters per second squared. I might just double check that. 9.81 minus 0.11 times 9.81 times 7.181 cos equals. Nope, I got the same thing, so I didn't screw up. I was just worried because it was tiny. All right, number 26. Oh, wait, no, I missed part on 25. The last part of 25 says, find the time it takes to reach the bottom of the ramp if friction is acting. So we want to know delta t. We know delta d is 12 meters, and we just found our a. So you're going to do delta d is equal to vi delta t 1/2 a delta t squared. This goes to 0. So delta t squared is going to equal 2 delta d over 2 delta d